welcome everyone to the session 4 of FHIR Basics series. And today we will be talking about conformance and terminology. So we will have an introduction to what's conformance, why is it important, and what is the importance of terminology in implementation of FHIR. And from there we will go. So before we get started, let me... So, as usual, the first thing we should be giving the credit to the people from whom we have taken the knowledge and borrowed the content. So these are the folks from the FHIR community who have helped in preparing this slide. So we have borrowed the contents from these folks. Okay, so today's agenda is we will do a recap. We'll talk about conformance, terminology. We'll do a basic exercise, and we will have a pre-work for the next session. Okay. So while since most of you are new to the session, I'll just take a few minutes to talk about the FHIR India community. As most of you would already be aware that FHIR India community is an open community. Anyone can be part of it. And it's open for people who are interested in learning FHIR, implementing FHIR, and overall healthcare IT interoperability. So it's a community of those folks, and it's not restricted just for engineers. So the community is having a vibrant representation from doctors, engineers, business analysts, policymakers, executives, everyone. This community is very vibrant and wide open. They make use of the community, get involved with the community. Discussion forum is the channel that where since we are at a size where no other communication medium is good. So that's why we have to move to discussion forum, and Zulip chat is one of the discussion forums that is serving us well. And the other thing is, if you are familiar with the Zulip chat, it's very seamless to move to the global chat versus the Indian chat. So depending on the context, you can switch. You won't have the learning curve and anything like that. And some of the users will be on both the places. A lot of Indian users are on both the chats. There is a LinkedIn group. Please do join the LinkedIn group as well, because that is the group where all the information, all the announcements, notifications, everything come there, right? So Zulip is for discussion, and LinkedIn is actually where the group on LinkedIn forms. The advantage of LinkedIn group is you don't have to register or sign up anything. You just be a member of this group, right? All right. So this is something that the community, for the folks who are new to the community, should just look at, right? What all things the community has done and is doing, right? So it gets involved with the healthcare initiatives of the government, of the country. The community was instrumental in launching the FHIR India Connectathon last year. It helped building the FHIR profiles for NDHM, and it does a lot connect with the global community, and it actually also pursues some projects of common interest. So if you are interested in any of these, just be on the watch out on the Zulip channels. There will be some notifications that you can make use of. So with that, we get to the housekeeping section, and from here the things get started. Please be mute while the session is in progress. Use your full name in the Zoom participants profile so that it's easy for us to know who is asking the question and respond to. Zoom chat is being monitored by Avanti, and so you can ask your questions in the chat, and at a right interval or right moment, she will chime in and ask the question. Even after this, and what I have been saying for last 1 month is, even after the session is over, the learning does not stop. The learning continues on Zulip. So take full advantage of that. and do follow-ups, ask questions, do discussions on the discussion forum, right? And make sure that you are on Zulip so that you can actually continue the discussion. The URL you already have and people have logged in, so we'll not go into the URL. So with that, we get to the first section of today's agenda, and that's the recap. So in the recap, the endeavor is like whatever we have covered so far, the important bits and pieces of it, we try to rehash so that anyone who is even joining new does not means have the connection and do not miss out on significant pieces, right? So it's never a replacement of attending the full sessions, but even if you have missed it and you want to attend the current session, you will have a good segue into it. Okay, so the first thing first. So first thing first, we are talking about FHIR, right? FHIR is an acronym. It stands for Fast Healthcare Interoperability Resources. It is a standard which is developed by HL7 International. HL7 International is a standards development organization which is credited to develop many healthcare standards, healthcare data exchange standards. For example, HL7 version 2, most of you are familiar with, was developed by HL7. Then clinical document architecture, the CDA is a very famous standard from HL7. HL7 did V3 also, HL7 version 3, but that was not a great success. And now HL7 has launched a new standard that is called FHIR, pronounced as FHIR, but it's spelled as FHIR. It's a new paradigm, new thought process, and we'll see what all those are. But in a nutshell, what you need to remember is FHIR is a new standard from HL7.org. HL7.org is a standards development organization. And FHIR, other thing to note about FHIR is FHIR supports multiple paradigms of exchange. So it supports messaging also, but the primary paradigm of support for FHIR is RESTful interchanges. And then it supports documents and services as well. Okay. So as I said, FHIR, if you say FHIR or talk about FHIR, the first thing that comes to anyone's mind is the FHIR RESTful paradigm. So that's why it makes sense for us to talk about the RESTful paradigm a little bit. Okay, so the RESTful paradigm is actually based on the REST architecture style, and the full form of REST is representational state transfer. Do not get into details of it, just that much is enough. Okay, the basic concept of RESTful paradigm is that your data is represented in form of resources. Okay, so the data is in form of resources, and there is a repository which contains all the resources. What you do is you interact with the repository and try to manipulate the resources. Okay, resources are, as I said, resources are on a repository, so they are addressable by a URI. So each of the resource will have a uniform resource identifier, or you can say uniform resource locator also, URL also. So any resource or any data in FHIR will actually have an address. Okay, and when we are seeing the examples, we'll see. Okay, so just like any web address, like www.google.com, there will be an address for, say, patient Satyam, right? So Satyam is a patient, right? And his ID is 1, for example. And the server is example.org, for example. So then patient Satyam will have an URI address, which will be example.org/patient/1. Okay, 1 is the identifier with which Satyam can be addressed. We'll see that in examples if time permits. And if the time does not permit, just go back to session 2 and you will see there. Okay. Now, we know now about resources. Resources are URI addressable. And then you use HTTP verbs, HTTP methods to actually do query and retrieve and all the CRUD operations on that resource. So for example, you can create a patient, read a patient, update a patient, delete a patient. So that's the CRUD, C-R-U-D, CRUD operations, right? And you
sorry,
can
excuse me, sir. Yeah, patient, create, read or update the patient or resources.
Patient was an example resource, so you can do for all.
Yeah, sure. Thanks.
Thank you. So, and that's a good point. So, patient I took as an example. It's about all the resources. Okay. And use HTTP verbs. Like for example, to create, you use the verb called HTTP post. For read, you do get. For update, you do put. And for delete, it's delete. Okay. Apart from that, there are certain operations that FHIR defines, which extend the capabilities beyond CRUD. So for example, if you have to, and today we will see some of those operations. So for example, if you have to do a lookup for a value set or expand a value set, you will use expand operation. If you want to get everything for a patient, you will do $everything operation on the patient resource, right? So some operations are actually defined which extend the functionality beyond the CRUD operations. So those are defined in the FHIR spec.
Sir, I have one question, if you don't mind.
Yes.
Actually, the FHIR, these operations, I mean, they like the create, update, or something like that. I mean, all the FHIR operation, it is executed on the top of HTTP methods, or HTTP method is the support of these FHIR methods.
So as I told you, HTTP methods are used to do these operations. So for example, as I said, like there is an URI for each resource, right? So each resource is lying somewhere on the server, right? Yeah. In order to execute, so for example, you want to create a patient on a server example.org, right? Then you will use the HTTP post method to post the payload from your client to the server, right? So that's how you are using the HTTP verbs.
So you mean the FHIR operations executing at the top of HTTP?
FHIR operations also execute on top of HTTP. You're right.
Okay, thanks.
Okay. So if for the interest of time, can you put your questions on the chat, and then Avanti will take a time to ask those questions so that we don't interrupt the flow in between, if you don't mind.
I'm sorry, no problem. Thanks.
No problems. Okay. But that was a good question, and hope that clarifies for everyone. So HTTP methods are used to do FHIR operations. Okay. Then FHIR resources are, so you can see FHIR resources, or you can exchange FHIR resources in different formats. So you can use XML or JSON or RDF or NDJSON, right, as different formats to represent the resource. In V2 world, in HL7 V2 world, we had this pipe separated EDI format, right? And similarly for CDA documents, we had this XML format, right? FHIR supports more than XML and JSON, right? It supports turtle format and NDJSON. NDJSON is nothing but new line delimited JSON that's used mostly in bulk data transfer. But that's where we should stop. RESTful, FHIR calls itself RESTful, but not completely REST, because there are certain things in REST which FHIR does not completely adhere to. That's why FHIR is a RESTful specification and not exactly a REST spec. All right. So FHIR, again, this was covered in the last session, that there are 3 levels at which you can expect a FHIR system to operate at. One is at the system level, it's base server level, right? Where if you want to do, like, get the capability of the server, right? What are the things that the server supports? That's a system level operation, right? You want to do a batch operation, right? Where there can be multiple resources and you want to say create or update all the multiple resources in one shot, right? You put it in a batch. So that's also a system level operation. Then servers support type level operations. Type level is like resource specific operations, right? For example, create a patient, search a patient, right? So that's actually at a type level, right? So the patient level, we are doing a create. We are doing a search, right? And then instance level. Instance is like actually not at the type level, but at the individual object level. So when we talked about patient Satyam, so instance level operations are actually at the level of Satyam, right? So there you can do a get for Satyam, you can update Satyam, you can delete Satyam, you can patch, and those kind of things, right? So individual instance level, right? So for a particular resource instance, the operations that you do are instance level services. So there are three levels where FHIR systems can operate and provide services. Okay, we talked about resources. So what are resources? We saw that resources are actually so the data is represented as resources, right? So resources become the small logically discrete units of exchange. Resources have a definite behavior and a meaning. So for example, if there is a resource for observation, you know that the resource observation will contain information and data only about observations. And what are observations? Observations are certain things that you observe, like patient's vital signs, or for example, lab reports, right? Those are the observations. And you know by the name observation itself that these are the things that this observation resource should be supporting. And if you go to the spec, you will actually see what does that resource mean and support and does. Okay. And as I said, each resource has its own identity and location on the server, and it's the smallest unit of transaction that we looked at. A more formal definition of a resource, again, you can just read it. I'll just pause for a minute. All right, so we go next. So examples of resources. What are resources and what are not resources? So for example, a patient practitioner organization is a resource. Similarly, a location coverage invoice is a resource. Allergy intolerance condition family. So these are all FHIR resources, right? And these are resources because they are logical entities and they can be fairly independent of each other and they can be operated on them. So bundle, binary, and composition are also resources. So there are around 140 plus resources as of today, and the resource numbers are increasing as we talk, right? So, but just keep in mind that if you think of gender or say age, those are not resources. Those are just elements or attributes of a particular resource. So keep that in mind. And more details about resources we covered in session 3. So you can just go and look at what are resources there. Resource definitions we covered last week. All the resources have an identity. They have metadata, and they have a base language, and they have a reference to implicit rules. Identity is the ID of the resource. The ID as in like the identification logical ID of that artifact. Metadata contains information about that resource, right? The version, the profile, the other things. The base language is in what language the resource is there, the language of the resource, and the implicit rules are certain rules which are actually implicitly applied to the resource. So every resource has these 4 basic things. Okay, but that is not enough. So there are domain resources. Domain resources extend from base resources, right? And they add few other sections, few other elements like human readability, then a type for contained resources, and then extensibility. So there are resources, there are domain resources, and then there are resources that we use in real life, right? So for example, a patient observation and all is a type of domain resource. Okay, because domain resource in itself is an abstract resource. But what it means is you can't use domain resource on its own. You need to have one resource which inherits from domain resource. Okay, and just take a look at the session 3 and you will come to know about it. Now, this is also the last slide of the recap. So where we talk about resource examples. So this is a resource. A resource, as we told, has a metadata, human readable element because it's a domain resource, and the example is a patient, then extensions, and then the standard data. And for more details, you can go to the summary.html to see this particular section. All right. So now we are getting to the next section, which is about conformance. And before we go into the conformance, it's important to know about the FHIR manifesto. The FHIR manifesto talks about focus on implementers, right? Means the focus of the FHIR spec is on the implementers. How do we make it easy for the implementers to implement? And then there is a target support for common scenarios. So FHIR does not claim to support everything. It says like, we will support everything that is required, that is common, that is most widely used, right? It does not require any specific tools and technologies. It uses standard cross industry web technologies, and things are free. Like the standard is completely free. Even the reference libraries are free, right? So the thing to note is that what today we are going to talk about is, and why conformance is important because of the second thing. You see target support for common scenarios, right? We will delve deeper into it today, and that will also help you appreciate why conformance is needed and what are the things that would be required. So before we get in there, what does support common scenarios mean? Support common scenarios mean, and this is I think it's an unwritten rule, but it's what it is, that FHIR spec only includes elements if the resource designers or or whoever is defining the resources are confident that the particular element, particular resource will be used or applicable in 80% of the scenarios. Right, so only when something is widely applicable, that gets into the base FHIR spec. What it means is there will be specific scenarios, specialized scenarios, corner cases, country specific, your healthcare domain specific, or your hospital specific workflows, which may not be supported in the base FHIR spec. So keep that in mind. For those scenarios or for those elements and attributes which are not covered in the base spec, there are extensions. So FHIR has a mechanism to do extensions. The extensions in FHIR are similar to the Z segments, but not as ad hoc. So the extensions in FHIR actually help you. So extensions are better managed. Extensions are defined. Extensions are published on a registry, and they follow a particular structure. So even if you get an extension that you don't know about, you will be able to understand it and process it. So that's the difference between the Z segments on V2 and the extensions in FHIR. The extensions in FHIR are more structured, more formal, and it's easy to understand and implement the extensions, even for a system which does not define it. Okay. The resources are simple and easy to understand and use because it is focusing only on the common scenarios. So think of a scenario where everything in the world was modeled, right? So for example, a patient would have taken care of all the attributes which are required for a patient anywhere in the world. Think how big that resource would have been, right? So but that is not the case. So what happened? Only if certain things are used across globally, then only it makes sense and gets into the spec. And because of that, what happens is the resource becomes very, very simple and easy to understand. For example, and example for this is, I think we take example of race, right? US race. So race is an extension that is used, or attribute that is used primarily in US. So the base FHIR spec for patient resource does not have an attribute for race. The US folks actually had to go with an extension to support race for their country. So that's how it is. Okay, so keep these things in mind and keep your questions coming up. Like, okay, if there is extension, if there are only 80% of the scenarios happening, right? How do we, and what are the things that we will have to do to make things interoperable, right? Just keep thinking on those lines and we will get into conformance. Okay. Take a minute, pause, reflect on the things that are covered so far. If you have any questions, put it in the chat. We'll take questions in the chat for next 3 to 4 minutes, and then we'll get into the conformance. All right. Any questions, Avanti, that we should be answering?
Oh, no questions until me.
Okay. So now we get into conformance. Okay. So what is conformance and what do you mean by conformance, right? So what exactly do you want by conformance? So conformance will be like, it will be how the systems work and how it should work, right? That's broadly conformance is, right? So if you document and describe it, that's what the conformance is, right? So you want to know how the system works and how it should be working, right? So that those two things, right? So, and it's a very, very basic thing. Just I'm trying to explain. What does conformance mean? Conformance means you want to know about how the system works and how it should be working, right? That's it. Okay. All right. So now you have a question, and this answers you can put in the chat or you can keep it with you. But here's the question. FHIR is a standard for interoperability. Okay. And this is something that we have understood. Now, the statement that is there following that, if two systems both comply with FHIR, they will be fully interoperable. Now, the question to you is whether this statement is true or false. Put it in the chat, the answers. And when we see the answer, just if you get the answer right, good. If not, you correct yourself. Okay. So the question is true or false. And the majority should be saying that it is false, right? Two systems we both comply to FHIR may not be fully interoperable, right? And there are various reasons for that. One is like because of extensions, because of variability, right? That could be one. The other things could be, we'll see. But this is another question. If you have answered no or false, give your answers in the chat so that we can take a look at them. So if you say why not, just answer them. Why do you think two systems which are actually implementing conforming to FHIR may not be interoperable? Okay. All right. So some answers are coming. Okay. So keep your answers coming in and we will go to the next, which will help you understand why not. So there are 140 plus resources already in FHIR and they are being defined as we go more, right? So do all the systems support all the resources? That's the first question. Maybe not, right? It's not practical for every system to support all the resources, right? The second thing is, even if they support the resources, if you have seen the resource definition last week, all the resource elements or most of them are optional. Even the data types, which are complex data types, their components are optional. And the terminologies are unconstrained. I mean, somebody can use line for observation, somebody can use SNOMED for observation, right? So this is the variability that you can get into, get with implementation of a FHIR server or a FHIR-based system, right? And then on top of that, there are operations and behavior. Somebody would put an operation saying that I will support delete every patient operation. Others will say that I will only support patient name and gender search. I will not support any other search, right? Other systems can do different kind of behavior. They can implement different behaviors because not all the behaviors make sense for a particular implementation, correct? So this is the variability that comes in with FHIR. So number of resources, then systems can choose what resources to implement. Implementers can also choose what behaviors and operations to support. And then within the resources and behaviors, there are like a lot of optionalities to deal with. Okay. So hope that answers why not. Why two systems implementing FHIR may not be interoperable, completely fully interoperable, right? And you saw the reasons. Okay. Now we talk about the need of having conformance, right? And conformance, when I talk about, it's more wide term. We can talk about it as profiles and profiling. So the need is to actually now define the variability and constrain the variability and document them, right? So the first thing that we need to document is what resources and what elements are to be used, are used in the system implementation, right? What API features are used, correct? What terminologies will be used? Should we be using LOINC or SNOMED, or are you going to use ICD or CPT? What, right? That should be documented so that a person who is implementing or who is talking to you, so for example, a client and a server, the client should know what the server supports, right? And then how do you take care of the local requirements? What are the extensions and other things that you're using, right? And this is not just it, right? So all these things should be done in a structured and computable way so that a person does not have to manually go and read and figure it out. The machine should automatically figure it out what it is and adapt itself accordingly, right? If you do that, then you actually make your systems interoperable, right? And that's where the FHIR conformance comes into play. A set of FHIR conformance guidelines, resources, and tooling actually helps you create structured computable statements about conformance, right? Which can be used for validation, code generation, reporting, maybe UI generation, and anything else, right? So FHIR conformance resources help you not only document the variability, also to constrain in them and also to report them out. And we'll see how. Okay. So how do you use conformance? You can use conformance to document expected behavior, test out systems, generate code, compare implementations that are compatible or not. So these are some of the use cases for having conformance statements, right?
Satyam, may I interrupt?
Yeah.
Yeah, there is a basic question. I think you should discuss that before we get into conformance.
Mm-hmm.
Does interoperability mean that the two systems are exactly alike? I don't think this is the goal of FHIR. Can you elaborate on that?
So two systems should not be exactly alike because they won't be in real world. But for interoperability and the semantic interoperability, So the definition of interoperability is that two systems should be able to exchange data and should be able to work on the data received, right, to attain their purpose, right? That's the goal of interoperability, right? And without significant effort from the user. Now, if you have to meet that expectation, right, what you need to do is you need to make sure that you document out the differences, right? And you also let the systems know how to deal with the variance, right? And definitely at a certain level, you need to make sure that the systems are compatible, right? So if, for example, some systems are using LOINC to report observations and the other systems are using SNOMED City, these are two code systems used to represent, in this case, observations, right? Now, these two systems may be interoperable if there is a concept map in between, which does the translation, right? So the systems need not be alike, but there should be a way that the system should be able to understand each other and function, right? So that's what the goal is, right? If the systems are following the same terminology, same code system, same profile, they should be more or less interoperable, right? So the goal of FHIR is not to make systems alike, but for interoperability, the system should be able to behave in a certain defined manner.
So can we say that in spite the systems being disparate, they can exchange information and understand the information? Right?
It depends. It depends on how you apply the constraint, because one of the basic rule of interoperability is the more strict you become, the better interoperability you get. Right? The more loose your spec is, the less interoperable you are. Right? So, for example, if you say that I only accept M as male for gender, right? Then anyone who is going to interact with you only uses M, and M is well understood, right? But then you say that I accept gender and anything is fine. So somebody might send M, somebody might send 0, somebody might send MLE male, right? Right. So though they are sending the codes for gender only, the systems may not be able to understand each other, right? So that's where the difference is. So the more constrained you are, the better interoperable you are. So there is a balance between how much constraint you can put on a system versus how much flexibility you want to get into the system. So when we are seeing the conformance resources, we'll get to see them, right?
Yeah.
To answer shortly, I think there is a balance that needs to be done. There is no straightforward answer, right?
Yeah.
In an ideal world, everything should be to the spec, right? No variation, right? So that there is no breaking of head, right? When you put in USB, it works, right? To get that plug and play interoperability, right? You need to actually make sure that the systems understand exactly what it is, what the data is, and what it is exchanged, correct? And that can only happen if the specification is very, 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 what do you say, tight.
Yeah.
And that is another reason why even if you have FHIR and even if you have hundreds of standards, right, healthcare will not be 100% plug and play interoperable in near future, right? Because I think there is too much of variation in healthcare. Okay.
That's right. Yeah.
Okay. Categories of conformance. So how do you make sure that the systems conform, and how do you document the conformance, and how do you actually constrain the systems and make them more conformant? So there are 4 categories where you can actually apply conformance. The first one is terminology. So terminologies conformance is like describe about how the systems are using your terminologies, right? So you can apply the constraints and document them at a terminology level. So what it means is whether the system is using a particular code system like SNOMED or it is using a LOINC, you can apply that particular constraint and document that. At a content level or the profile level, what you can say is like if I'm using a patient and an observation resource, then name is always mandatory, right? You can put that kind of conformance in the constraint, and that is called profiles. You can apply that. That is in the content level. Then at the behavior level, it's more about the API operations and the searches that you're going to support. So that's a different, I say categories is the wrong word, but that are different levels at which you can do the conformance or constraining, right? And then at the management level is about how do you publish the implementation guide and all, you can do that. Okay. So with that, we come to profiling FHIR. So what does profiling FHIR mean? Profiling FHIR actually means the act of creating profiles at in a very, very short way. That's the one. Profiling FHIR means the act of creating profiles, right? But what exactly it means is actually it means creating and documenting constraints, right, on the system behavior, right? So take a look at profiling.html, where you can get more details about what is profiling. But what does profiling use, right? So there are multiple resources in FHIR that are defined, which can help you with your profiling, okay? The first one, we can start from the bottom. The first one is profile. The profile is actually a set of constraints on a resource represented as a structured definition, okay? So profile is nothing but actually you take the base resource or a resource which is already profiled and add your own constraints on top of it. So that's the profile, okay? Then on top of that, there are some conformance resources like value set, right? So where you define what are the terminology codes that you can use. Then there is package and the implementation guide. The implementation guide is where you document the entire conformance resource, the profiles, the value sets, the code systems, the operations behavior, everything, and you put it in a implementation guide. So these are different resources that are available. We will look at profile today, and we will look at terminology today, and the rest I'll let you know like what to do. Okay. So first, what is a FHIR profile? And this was a question that somebody asked on Zulip chat also. So FHIR profile is to understand basically is actually a set of constraints on a FHIR resource, and the FHIR resource is just one. You can actually have a constraint on another profile also. So for example, the thing that happens, and this is very typical, is you have the base FHIR. On the base FHIR, then the countries say that, okay, at a country level, just in case of US, for example, they wanted US score to have race, right? So they did a profile on patient and say race is mandatory for patients in US, right? And then a particular hospital or a particular region can actually work on the US score profile and further constrain it. So constraining can be done on a resource directly or can be done on a profile also. Okay. So what does profiling a resource look like, right? So if you see in a resource, right, and we can go to the spec also, you see everything is, or majority of the thing is 0 star, right, which is optional, right? And some are like 0 to 1, again means optional, and if it is there, it can be 1, right? So then the first thing is you can constrain saying that, and this is just an example. You can use any of the more examples. This is just an example that I took from one of the slides, which says that if you are going to constrain a patient and make it conforming to your national standard, for example, the first thing that you can say that, okay, the identifier for the patient says that any identifier is good. So a PAN card, an Aadhaar card, a driving license, anything is good. But you can actually do a profiling and say that, okay, Aadhaar is mandatory for a patient in India, right? You can do that kind of constraining on FHIR, on a resource, right? Then you see here, in this case, the name is repeated. So name can be absent in a patient resource, and it can repeat multiple times, right? You can very well say that a patient without a name does not make sense, right? So at least once there should be a patient, right? And then you don't care about patient having multiple names, right? Does not make sense. So you can constrain it and say that patient name will always be present and it will be just once, right? And similarly, you can go ahead and do different kinds of customizations and constraints. And in this case, race code is not there in the patient resource. So you can add an extension to make a race code also, right? So this is about constraining and profiling a resource. Just a quick glimpse on what all things you can do, right? And this is not everything that you can do, right? So constraining and extending are just the base of profiling, but you can actually do much more than that. And we will see those. Okay. So this is the profiling that you are doing, the constraining and extending you're doing at a structure level, right? So at a patient definition level, right? So at a resource definition level, you're doing it, right? But then you can also do at an attribute level, right? So certain attributes are coded, right? And those coded attributes you can also constrain, right? And that is where you will get into profiling terminologies, right? Where you are actually constraining the terminologies that are used for a particular attribute. And there are primarily two things you do in a terminology conforming. One is you make sure that a particular attribute uses a particular kind of terminology. For example, in India, there is a debate whether we should be using loink or snowmade, right? So somebody can come up and say, binding will always be snowmade, done. So that is profiling. So for observations, always snowmade will be used. And then the binding strength says, what is the strength of the binding, whether it is required, extensible, example, or preferred, right? We will see in current NRCS, NDHM profiles, the binding strengths are actually referred as preferred. What it means is the guideline says that you should be using the binding that is given here. That is the preferred way of doing things, but it does not mandate anything. And we will see that. Okay. So before we get into this, I will take a pause and then we will talk about terminologies and then we will go back to the resources. Okay.
We have a few questions here.
Yes, you can ask few questions. And in the meanwhile, what I'll do is I'll go to the FHIR spec now. Yeah.
Yeah. Okay, before we go to terminology profiling, here are some questions regarding patient.
Yeah.
Yeah. So in my own profile, can I specify that email ID is the unique identifier for a practitioner?
What's the question?
In my own profile, can I specify that email ID is the unique identifier for a practitioner or a doctor?
Technically, you can. But you remember, like, what is an identifier? Identifier is something that gives a special identification to that particular thing, right? So very well, you can use an identifier, yes, as an email ID. Doesn't harm, right? Means, yeah. I think we are using phone numbers definitely, right? So if you can use the phone number, you should be able to use email IDs also. But the only thing is the email ID will be defined as an identifier, right? And it will be separate from the email ID that you are defining in the communication, right?
Yeah.
But you can use it.
Okay. Why default FHIR resource as name as optional, not as required? We had that question last time also.
So the answer is FHIR is a platform standard, right? So it tries to make sure that the base spec works in all the scenarios, right? So there could be a scenario where patient name is not required or not used. Now, I don't know what scenario it will be.
Arun Kumar has specified that FHIR can be used for research, population health, etc. Where
that's a good one, right? So in research, you can do a de-identification. In that case, you don't need the name, right?
Yeah, anonymization.
That's a good one, right? So that's why the FHIR is a base platform standard which tries to make sure that it works in most of the scenarios. and that's why it has preferred to be loose than strict, because when you are strict, right, you don't know in what standard, what scenarios things will fail, right?
Yeah.
And the other thing that to note when you're doing a profiling, and that's a rule of profiling, that you can only constrain and extend, you cannot relax, right? So if something is said that it's mandatory in the base, right, you cannot make it optional, right? But if something is optional in the base, you can always make it mandatory, right? So because of these kind of reasons, I think the specs is more inclining towards being loose and optional, so that it knows that most of the implementations will definitely profile it.
Yeah, another question, rather concern from Dr. Sudha. Unconscious patients in ER, that is the emergency room, where they can assign a dummy ID, but name would be left blank.
Yeah, that's a good example. Yeah, where the name is not required or not known.
How to get resource details with reference resource details?
What is the question?
I'll repeat it. How to get resource details with reference resource details? I think Baburao, can you just elaborate on that, please? Can we unmute him?
Yeah, anyone can unmute.
Yeah, please.
Yes.
Yeah,
Yes,
please go
yes.
ahead.
Yeah. Actually, I have patient resource and also appointment resource related with patient, particular patient. So I want to get both resource details
Yeah, you
as
can.
search.
So you go to the search in the FHIR
Mm-hmm.
script and look at the include and reverse include functions. And
Include and reverse.
include and rev include. So there are two, you can use two operators to actually get reference resources if they are supported. So, and this we covered in our FHIR, what do you say, RESTful API. So session 2, you can take it there as well.
Okay. Yeah, I'm asking because I need to implement that relationship in
Yeah, it's a
my project.
so include and rev include are should help you.
Yeah, thanks. I
Uh,
will check.
Okay, I think we should now move to the session and then we'll come back.
we have similar questions, but we'll take it ahead. Yeah.
Yeah. Okay. So what I'll do is now enough of slides. What we will do is we'll go to the terminology module, and this everyone you can open on your laptop and desktop and see, like, so go to HL7 FHIR terminology module.html and we'll follow there. So okay, it's the terminology module. Okay. And this is a good diagram that I felt that people should understand, and this will help you in working with FHIR and working with terminologies, right? So if you see this diagram, there is a naming system resource, right? There is a code system, then there is value set, concept map, element definition, and element instance, okay? So naming system, let's take what's the meaning of a naming system? Naming system is just a resource which defines a particular, what do you say, identifier for a particular type of a system, right? So that's the naming system, right? So for example, this is a naming system, snowmed.info/sct is a naming system. Just keep that in mind. Now the code system is a resource which actually, and there is an example that I have kept it here. So this is an example of a code system that will help you understand. So a code system is something like a definition of related terms that is defined by entity, right? So for example, Snowmed City is a code system that defines a lot of terms, right? Loink is a code system, right? So those are the code systems, okay? So code system is actually a system which has a lot of codes, which has definition of terms, right? And then the next one is a value set. What is value set? It is actually a subset of the codes that are coming from one or more code systems. So that's value sets. Okay. Understood the difference and understood what is the meaning of a code system and a value set. Code system is definition of terms by a particular entity, right? So for example, Loing, SNOMED, CPT, ICT, these are all coding systems, right? And they have a lot of terms defined. And these are the terms defined by these coding systems, right? And here, for example, they have said SNOMED City is a coding system, which has a lot of terms. Okay. Value set is a section or a selection of codes just for a particular use case, right? That's a value set. So for example, take an example. What can you take an example? Here they have given an example. SNOMED fracture codes. So you just want to have a value set which corresponds to only terms which represent fractures in SNOMED, right? So that's a value set. Okay, a selection, a subset of codes for a meaningful purpose or for a purpose. That's a value set. Okay. Now, in the element definition, and we'll look at the element definition, we will see this. So whenever you're defining an element, right? So for example, whenever you're defining an observation, right? Or whenever you're defining a particular attribute which needs a certain kind of terminology binding, right? You actually bind it to a value set. Okay. So the elements in a structure or a resource point to a value set. Okay. Clear? And then, but the actual objects that you are putting in your patient payload or a resource payload, right? They will actually be referring to a code system. Okay, so value set is just for referral purpose, just to make sure that your logical representation is correct. And we will see some examples. Okay, and then somebody was asking a question about what if two systems are in two different codes and what happens there. There you have the concept of a concept map. A concept map is a resource which actually does the translation or has the mappings for the source code and the target code. So you can use concept maps in case you want to do certain kind of translations. So this is an important section, terminology module. You should go through it. It's a very small section, but quite helpful. Okay. Now, in terminology, in FHIR, what are the key things that we need to deal with? Okay. The first thing is we talked about certain resources, right? We already have the definitions for them, right? The code system. We understand what is a code system. The code system is actually a system which defines terms, right? That's a code system. Example is SNOMED, Loing, ICD, and all, right? Value set is a subset which can derive codes from one or more code systems. Understood? Concept map, we understood. Concept map is about translations. Naming system is naming that naming a system or naming an identifier. That's a naming system. And terminology capabilities is actually capabilities. How do you define the terminology capabilities of a system? Okay. So these are the resources that you will come into play when you're dealing with terminologies. The most important ones or the most frequently used ones will be the value set and the code system. And if you are dealing with translations, you will be using concept maps. Okay. Terminology service is actually different. So if you are implementing a terminology service, what should it be? Right? That documentation is here. Okay. Do not need to worry about it. Then so if you are implementing a terminology server or if you are providing a terminology service, there are certain sets of operations that you should be doing, right? For example, at a code system level, you should support lookup. You should support validation of a code, right? Find matches and subsumes. I don't know all the details of these operations, but for example, lookup, you want to look up a particular code and see whether this code belongs to this code system or not. Your system should be able to support that with this operation. Similarly, matching. If you want to match a code for a particular system, your server should be supporting it. Similarly, for value sets, expand. So as I said, value set is nothing but a subset of codes from one or more code systems, right? Now you become a logical grouping, right? And generally value sets have a name, okay? And those names are referenced in most of your bindings. Now, as a client or as the system which is implementing, you do not know what this name means because value sets are very specific. What you do is you do a $expand operation and you say, okay, for this particular value set, give me all the codes that are in there, right? So that's an expand operation. Validate code is similar, whether this code belongs to this value set or not, right? In the concept map, you have translate, given a source code system and code, translate it to a destination code system and code. So translation from SNOMED to ICD, ICD to SNOMED through concept maps. We'll, if time permits, we'll see one or two operations also in practice. Don't worry about it. Okay, and if not, I'll share with you the Postman collection, or we can do in session 5 also. Okay, so
Tim, is it possible to repeat the example because we have some concerns here?
Which example?
The terminology thing. I think it is not that clear.
Which example?
The same example, maybe.
I do not understand.
Just a moment. Well, we had a question regarding can we have an example for the current slide? That means this slide.
Slide?
Yeah. This
one.
I'm sorry, Satyam, this is Tanvir here. I just want to understand with an example of the terminology module, like do we have any resource where we can see the live example?
We will get in there. We'll get in there.
All right, yeah, that was my question.
First, look at this page and then we'll go to the resource. Okay. So because these are the things that you need to keep in mind, because when you're looking at the resource, you'll look at all these things. So you need to know the definitions here, and then we'll see the examples. Okay. Then we will be primarily dealing with 3 types of data types which come into picture when you are dealing with codes. One is code. Code is a data type. Okay. And code is a data type which you use when the understanding is fairly straightforward, right? And the code data type has only one attribute, that is called code, right? So for example, status, example is a status. A status, if you see, it's a, I will see that, okay. So that is code. Then coding. Coding is a data type which has actually the system, the display, the code, and the user defined. We'll see all those things, and codable concept. We'll see. Codable concept is nothing but coding plus a text. That is a codable concept. Okay, I will see where to use what, and then how do you use codes in or terminologies in resources is documented here using code in resources. We'll not go into that. Okay, and then there is nothing much here. So now what we will do is we come here. Okay. Okay, so this is the definition that I was talking about. Code plus system plus display plus version plus user selected and all. And now let's take a look at patient resource. So see this, we had this planned. So we are going to the patient resource now. Okay. Are you following? Are you all on the same patient resource page? I hope yes. Okay. So again, just to rehash what is a resource definition page looking like, right? So every resource, if you go to resources, every resource has a definition, right? So resource definition. So right now we are clicking on the patient and we're going to the patient resource definition. Patient resource definition has, and any resource definition for that matter will have what is that particular resource about? What is the scope and usage of that particular resource? Okay. Then what is the structure of that particular resource, right? That's defined, and that structure can be represented in structure, then relationship in UML, in XML format, in JSON format, and all different formats. So research content can be represented in various ways. Pick your format that is you are most comfortable with. And then here is the definition where the left-hand side, you have the resource name, and then you have attributes. Then you have flags, you have cardinality, you have the data types, and then you have description and constraints. Okay. In the last session, we covered about how to read this. We covered about flags and cardinalities and data types. Today, we are going to cover about the description and the constraints. Okay. So now take an example. Let's start with the code. So we talked about terminology as code, so code as a data type, right? And what we said is code data type has just one attribute, which is called code, all right? So let's go to the data type. It's minimized. So it's not very clear here. Let's go to an example of the patient, and you'll see there. So you go to example, and you go to JSON example of a patient, and we are seeing what is the code we wanted to see? Gender. So active is also a code data type. So you see this. Where is active? Where is active?
MR itself is a code, right? On the top. MR.
MR is a code, but it's inside coding. So coding is a different data type. We'll come to that. So first I'm going to the code data type. So code data type is just direct. You say the attribute and you just say the value. Okay, that is the code data type. So here, where did patient go?
Satyam, may I suggest something?
Yeah.
Can you go to the observation resource so they have some clinical values that might clear out things?
No, in that observation, there is nothing called code. That's the problem.
Nothing in the
there is a status. There is a status. But here in patient, you have all the different variables. That's why we pick that. We'll go to observation also. So gender, you can directly say male, female, unknown, right? So that's about the code. Code has just a code. You can directly say it, code. Okay. And example, let me open it as a Control C, Control T, Control V. Okay, and we go to the example, and we will look at patient resource once. And let me copy it so that we can look at it in a good. We copy this. We go to. Okay, let me go to Notepad++. Go to here. Go here. You can say language. Language is JSON. Okay, and Control F. Gender. You can say, so when the data type is code, right, you can directly say the value, okay, with the attribute. So this is a data type of code. Understood? Then you have, so while we are here, we will see another called codable concept. Now this guy, marital status, is codable concept, okay? A codable concept is a data type which has coding and text, two attributes. Okay, and coding itself is a data type which is having so many things. So now if we get the example of marital, what was it? Marital status, right? So marital status, this patient does not have a marital status. So let's see something else. Maybe organization is observation is better, right? Please ping if you are not following anything, right? So we will just try to explain that one more time. Are you guys following till now? Or lost? No answers?
Well, there is a yes.
Okay, fine. If you are lost, because the whole purpose is to make sure that things are understood, right? So these things are theoretically a little bit confusing, but when you start working on it, it's very, very simple. Okay, and so let's take, for example, here, status we saw. So whenever there is a data type called code, all it means is directly to the attribute, you can write the value, correct? So that's about code. When it is codable concept, you actually get into details. And let's see, category and code, right? So there should be something here. Control.
Typically, category is there in observation.
Yeah, so I'm in observation only. So you are seeing code, right? So here is a code, right? Code is of type codable concept, right? So what it means is observation code attribute, you have to give these values, right? You have to have coding, and then you should also provide text. In this case, they have not provided text, but that is what it means. Whenever a data type is codable concept, you actually have to go with the code, and then under the code there will be coding, and there should be a text. Okay, and codable concept has, if you see, what happened? Multiple codings that you can have. So when do you use codable concept, right? So what happens is, if a certain thing, right? So you want to represent, say, a disease, right? And that disease can be represented in multiple terms, right? So for example, you want to represent a disease in SNOMED, and you want to represent a disease in ICD also, right? Right, because it's you want to make sure that the system understands, receiving system understands in whatever way it wants, right? In that case, you want to specify multiple codes, right, for the same thing, right? So for typhoid, you are trying to represent typhoid in two different code systems. One is in SNOMED and one is in ICD. In that case, it's very, very useful to use codable concept, because then the same meaning can be represented in two different coding systems, right? And that's the beauty of codable concept. And that's where primarily the codable concepts get used. Okay. Codable concept also has a text. If you see here, it also has a, where is that codable concept? Codable concept has plus an optional text. So what it means is, since you're representing a term in multiple different code systems, right? So you're representing typhoid in SNOMED, you're representing typhoid in ICD, you can also select a user-defined text that can be going and saying that this is what I mean, right? So that's when you want to represent certain things like that, you use codable concept. Okay. Understood the difference between a codable concept and a code. Is that correct?
Satyam, can you just open the administrative gender value set and the marital status value set? Maybe
we'll get to the value set. We'll get to the value set. Right now, I am just here on the type only. Then we'll go to the value set.
It's Mr. Satyam. This is Dr. Sudha. Can I just say the difference between code and codable concepts is that the code, what I have noticed is, it's pretty much fixed and it comes with the base resource.
Yes.
All the options. Whereas in a codable concept, it is left loose, and it is for the users in the implementations to define whether they want to use, like example, LOINC or SNOMED or ICD. I mean, whichever they want, depending on the resource. Is that right?
You are getting the point, but it's not exactly that, because the code also, right? You can make sure that the code can be extended and all, right? But generally the code is used when the meaning is well understood by everyone, right? So for example, status active, right? Everyone understands, right? So in that case, you don't need the system and other things, right?
Correct.
But
and also noted that it is more of, resource, the options where it is globally understood values, where
that is where code you use the
correct.
code.
Yes, exactly.
Okay. But if there are things that are like multiple code systems exists and you can represent in SNOMED, ICD and all, right? And it depends on external code systems. Generally, a codable concept or a coding are used.
Yeah.
Okay.
Thank you.
But sir, the coding system, for example, the SNOMED series, something like that, it is related only with some few resources, not with everyone. Am I right?
So it depends. So wherever the data type is code, wherever the data type will be either code, codable concept or coding, right? You will definitely have one of the value sets defined. And that value set can come from any of the coding systems.
No, I mean the coding system is used for only few resources, not for all.
What do you mean by that?
For example, like the diseases. So
yeah, so if you see here also the coding system is used, right? So for gender also they are using, right? For marital status also they are using. So yeah, not for everything, but for the things that need to be codified, you use that.
For example, for gender, the coding system is coming from which system? SNOMED?
No. So for the gender, what you are here, it's just of a type code. What it means is you are not specifying the coding system.
Yeah, that's what I'm asking. I mean, that the coding system, like for example, you mentioned the SNOMED or CT, ICD, or something like that. It is only for few resources. I'm sure it might be for 3-4 resources. Because mostly we're talking about the diseases and all these things.
You're confusing resources and attributes. So what you're talking about is attributes, right?
Oh, yeah.
Yeah. So yeah, it's not for all the attributes. Only the attributes which have a codable concept.
Yeah.
Or the coding, you need a code system or you need a value set.
Yeah.
Okay. So let's get into that details. So now you understood the difference between the codable concept and the coding, right?
Yeah.
Now what we need to do is the binding. So what happens is when you define a data type as code or a coding system, you need to provide the binding, right? Binding as in like it binds to what code, right? Or what value sets. So if you go here a little bit below, and this is also I'm explaining how to read the spec. So you go to a resource, you have seen the resource purpose, scope, resource content definition. And if you go a little bit below, it also gives you the terminology binding. Okay. Means what are the terminologies binding for particular attributes of that resource. So here, as you mentioned, Ayaz, that not all the attributes have terminology bindings. Of the patient, only these many have terminology bindings. Okay, and if you see here, the thing that you need to see here is the type. Okay,
yeah,
terminology binding type, and the binding type is actually what is defined as there are four binding types, and we will see the binding types if I click here. So there is a binding type called required. Okay.
Yeah.
And so this is called binding strengths. So it's required, extensible, preferred, and example. When you say something is required, right?
Yeah.
What it means is the implementer does not have a choice.
Yeah.
Whatever you have defined in the profile, people have to follow it.
Yeah.
Okay.
Of course.
When you say extensible, what it means is there is a binding that is defined for that particular attribute. Okay, you should be using that. But if you don't find the code that is appropriate for you, you can actually extend it. Okay, that's extensible. Preferred is, again, as we said, like preferred is when the profile definition or the person who is defining the profile or the spec definer says that you should prefer SNOMED CT. That is the preferred binding, right? But preferred does not mean mandatory. You can choose to differ. Okay, it's more of an encouragement. Okay, an example is like, it's just for example's sake, and you can choose your own terminologies. Okay, now let's go to patient. So here, if you see here, gender is required. What it means is you can only only use the values that are defined in this particular value set, administrative gender value set. And what are the values that are defined in here? It is male, female, other, and unknown. Okay, so that is what the required means. You're getting me how to read this? So for patient gender, the binding strength is required, and it is bound to a value set called administrative gender. So your values for patient gender should always come from administrative gender. Okay, understood? Now for marital status, your binding strength is extensible, and the value set they are saying is marital status codes. So if you look at marital status codes, so these are the codes that are defined. Okay, so your binding or your attributes should come from any of these codes. Okay, but if they are not there, you are free to extend. Okay, that is extensible. Now you see the language, right? Language, it says preferred. Okay, what does preferred means? Means you should prefer to use this particular value set that is defined in here. Okay, so that's the spec definer's preference. Okay, this is the language codes that is preferred here. Understood? So that's the difference between the binding strengths. Any questions so far before we move to the next? You can ask your questions, no problems. We are already shooting our time, so you can ask 1 or 2 questions.
So Ashok Kumar wants to ask the question regarding the IG.
We also covered the coding part.
Which part?
The coding data type part. We thought we would cover it later, right?
So coding data type is actually in codable concept itself. So codable concept contains coding. So if you see here, this is coding.
Right. So in this particular scenario, right, if I have to get a patient record based on a particular code. So let's say we were talking about the medical record number scenario. So a patient might have multiple medical record numbers. So, and each medical record number is tied to a particular code type. So if I do not know a logical ID or else any other.
See, medical record number falls under the identifier type. Okay. So if you go to patient. Okay.
Yes, I was going to interrupt. How do you have multiple medical record numbers?
No, hold on. So if you see identifiers, if you look at identifier is a type. In identifier, you have a codable concept, right? And a code. So here you can repeat multiple times. So you can have a type as MRN, you can have a type as a social security number, you can have a type as Aadhaar or whatever you want, right?
Yeah.
That's how you repeat it. So, but your example for medical record number was more of an example of identifier.
Okay. So would you be able to help us understand how we can perform a query based on that particular ID? So in that scenario,
yes,
right?
We actually, so if you get to session 2 or maybe after this session, we can look at it. Or if you ask on the Zulip, right? Okay, I will provide you the examples there. Actually, I did provide the Postman collection for session 2. If you look at that Postman collection, there should be some answers for you. Okay. And if not, just put in a question there and I'll give you the example.
Yeah. Thank you.
Okay.
See, if you see the codable concept is a combination of coding and text.
Correct.
In implementation guide, I've seen the codable concept does not mention the terminology binding.
how we are going to represent such thing.
No, every codable concept should have a binding, right?
I'll share the link in the chat box. You can see that one does not have that terminology binding.
Which chat box you are talking about?
Yeah, you can.
Yeah, is it build.fire.org DaVinci?
Yeah.
Okay.
Something about the insurance plan, specific cost category.
Let me look at it.
You need to click the IG maybe.
So this is detailed description. You need to go to the content, Ashok, for the binding.
So let's look at this.
Ashok, can you please mute yourself? It is causing a disturbance.
And you go to the content and you go to, what was the particular thing?
These are the ones.
So these are the ones that are already there, and you have the value set binding already there, right?
The last one, specific cost.
So it has, right, benefit, cost, applicability, it's there, right?
Right, Ashok Kumar? This is what you meant? Or something else?
No, it is not there.
He's mentioned insurance plan dot specific cost dot category.
Where is that here?
That's what I'm finding. No, he's saying it is somewhere else.
Okay, we can take that on Zulip. Okay, so if that is a specific thing, and we can debug that and let you know what exactly it is. Okay.
Yeah,
for the interest of others. So that's the basic of codable concepts and coding and terminology bindings that you should be aware of. The other thing that if you see the difference and that you should have noticed is when we look at the example, right? The example is Loink. So for example, coding is loink.org, and then this is it, right? And if you go to observation, and you go to code, yeah, it's actually Loink codes here, but it's a value set here. You see, this is a value set, okay? But your actual instance always has the concept name here, because value set names can be different. Okay, so that is another thing that you need to know, right? Whenever you are defining the value in your instance, your system name is actually the what is it called? Coding system name. Then the code is the actual code, and the display is the actual display value. Okay. And I'll just come back to it. Let me just go to, okay, so there are certain resources that we need to look at it, and since we don't have time today, what we can do is we can look at it tomorrow, or if we have 10-15 minutes more, we can just finish it.
Satyam, this is Manoj. One quick question before we proceed.
Go ahead.
The question is regarding, I think Avanti missed my question. The question is basically the how on the FHIR website we can see all resources available. The definitions are there, right? So if whatever we need, we can just go there and get the template from there, right? And then later we can modify based on our requirement.
True.
Similarly, do we have similar thing for the extensions, or it is purely user defined?
No. Extensions, there are registries. So if you see here, there are extensions. You see.
Okay. Yeah. This was the question. Okay.
Okay. So you have extension registry. See, the end goal is interoperability, and interoperability is when sender and receiver understand the meaning, right?
Correct.
And for that, it is encouraged that first thing is when you are trying to define an extension, look at whether that extension has already been defined.
Correct.
Try to use that.
Yeah. That was my question, and you answered it. Thank you.
Okay.
Thank you.
Fine.
Yeah.
All right. So if you have time, I'll just go back to conformance, resources, capabilities. So capability statement is okay. Let's go to Postman now and let's do some fun. It takes some time. So capability statement is actually a conformance resource which gives you the details of a server, right? So a server's capability, that's the capability statement. It gives the details of everything that the server supports or does, right? Even who is the author, what is the software running, what resources it supports, what operations, everything. So the first thing any implementer should do is to actually look at the capability statement with the server they're planning to work with, right? That's the first thing. And capability statement is the only resource that is required to be supported by a FHIR server, right? So if you don't find anything else, you will find a capability statement if a server is FHIR compliant. So it's like that. Okay. Moving on. Operation definition. Operation definition is a resource. So if you want to define custom operations, right? So you want to define an operation of book payments, right? You want to define a custom operation to book payments for your website, right? And that is not given in the FHIR spec. You can define that operation using a standard construct called operation definition. Okay, so that's the operation definition. So if you want to define different operations, structure definition. Structured definitions, all the resources, right? They have a structure, and that structure is like the structured definition, right? So whenever you're doing a profiling, what you do is actually you create a new structure, right? So you define a new structure for that particular resource. So profile is nothing but a new structure, right? Which is more constant. And we'll look at one structure definition. Okay. A value set, as we know, value set is a resource which contains a subset of related terminologies for a particular purpose. Concept map is translations, and naming system is just for naming, right? So issue and identification. Now let's go to Postman and do some operations. So first, server capability. So server capability is available at, so this is the base of the server, and metadata is the endpoint. If you hit the metadata endpoint with a GET request, you should get the server's capability. Okay, and let me copy it. Let me go in here, Control N, Control V. The language is XML, so I'll make it XML. And it takes a lot of time because it's a big one. And if you see here, this is the capability statement, and this is the resource that I talked about. It talks about who the publisher is, what is this server, what kind of formats it supports, and everything, right? What resources it supports. And the good thing that you need to see also is, okay. So whenever you see a capability statement, there are two types of profiles that you will see. One is the profile tag, and this is under, what is it under? So it will be in the capability statement and rest dot resource, okay? And under the resource, there will be profile and supported profile. Profile is the generic, the baseline structure. So allergy intolerance, the base allergy resource. And then the supported profiles are the customized profiles that people have created, which this server also supports, right? So if you want to know whether this server supports a particular profile that you are going to work with, take a look at the supported profiles. And I did load NRCS profiles here. So let me see if NRCS is here. Okay. So I did load a profile from NRCS. NRCS is our National Resource Center, which have defined NDHM FHIR profiles. So I was playing around with it. So what I did was I loaded the NRCS profile onto this server and made the server support that particular profile. So now I can see that is supported. Okay. So I specifically did the condition resource. Okay. So this is one thing that you need to know. So in the capability statement, you can figure out whether your server supports the profile that you are interested in or not. And then you can look at operations. Okay. And you see different types of operation that is being supported. So meta add, delete, and all. I am just using your server. So if you go to the NRCS website, they have defined FHIR profiles for NDHM. NDHM is National Digital Health Mission, the Government of India initiative, right? And in that, they have defined a lot of resources. Okay. You take a resource, for example, I already did for conditions. So let's take something else. Let's take patient. Okay. I hope patient is not here. Or maybe even if, okay, let me search with NRCS. Oh, so patient is not there. So we can load patient. So if you come here, you see that they have done some customizations, and this is where it is important, right? So the differential views. So in FHIR, the profiling, FHIR supports two type of views. One is differential and one is snapshot. Differential only gives you the differences from the base, what the profile has implemented, right? So if you take a patient, for example, so we are looking at patient, right? In the patient, they have added a lot of S. You see that they have added a lot of S's, right? And that's why it's in the differential view. And then they have added some code systems and other things, right? So this is the differential view. So they have made 3 elements mandatory, certain elements must support, and then they have fixed the value of one element. So this is what they have done. Okay. With me so far? So now what we will do is we will download the JSON that they have and try to open in folder. Control C, open with Notepad++. What happened? Did it open? Okay. Okay, language is taken as JSON. So if you see this, this is the structured definition. Okay. So when you construct a profile, you actually get a structured definition. And all you have to do is you just load this structured definition in the FHIR server that you want to support. And then that FHIR server actually starts supporting your profile. You understood so far?
Please come again. Maybe you should repeat that.
So I think people are lost now.
Yes.
So maybe we'll continue then next time. Okay.
So Satyam, can you load it? This particular one profile.
Yeah.
I wanted to
exactly.
load if people should be there, right?
No, I think all are mute. They're quite engrossed with your session.
So what we can do is, let me see where
I think it's better, Satyam, we can continue with the next session so they will be fresh-minded so they can easily understand this.
Yeah, I think, sir, can you shift this topic to the next session?
Yeah.
Yeah, that's good.
Okay, so fine. So what we will do is, before we drop off, what we will do is we will just post that structured definition and then get done with it. So validate structure definition. So what you do is you go to this endpoint, okay, structure definition endpoint. You go into the body and you put the structure definition. Okay. In the headers, you put the content type as FHIR JSON and you just say send. And that should be good enough. That is created. Okay. And if you do a get of metadata again, you should see that. Okay. And if you do a send and you search for NRCS, so right now it is not saying, so it takes some time to refresh because it is coming from the cache. But if you see it later, you will get it.
Satyam, you are checking with different endpoint.
Is it?
Because yeah,
no, it's the same.
These are happy and for structure definition you tested on test server.
I did. No, I did it on test. Okay.
Yeah.
You're right. So I think it's time for me to also stop. Okay. Sorry.
Big.
But I have to do a get.
Big get.
And I do metadata. It's taking time. And we do a search. And we do NRCS. What happened? Did I post it here only? Let me post it to the base thing, right? This is the happy base, right? Copy. Where did my expand go? So maybe I think we can do it next time because I think a lot of things are there.
Yeah, I think so.
Just a minute. Hold on. Let's complete this and then let's go. Structure definition. Then you just say in the body you go to raw. You come here. You can't copy. Put it here, you paste it. In the header, you say content type. So this is other thing that you need to know is the content type is always FHIR plus JSON, right? Hopefully it works.
Wait. You have not changed the.
What have not changed? And in the header, you already have the structure definition that is created, right? So it's here. Okay, so it should be available in your metadata. So now if you copy this and go to the metadata and you just take it, it should be here.
Satyam, it's a bad request saying.
So you type metadata.
We have not given metadata.
Good, you guys are attentive. So what did we upload? We uploaded patient only, right? So we uploaded patient and we uploaded to this guy and this guy already has it. It's here. So other thing that I have observed is like it's a little bit caching that happens. So let me do a get first and see if it is source type and what is it? Control F. Okay, copy. Here Control N, Control V, and you go here. It's a resource extensions and it is for patient. So snapshot, it's for patient. Okay, so it should have come. Maybe we should do a. So do one thing. I think while there could be something missing here, just take this example, right? So the exercise that I have given you at the end of this session is actually look at this conformance rules, right? Go to this page, right? And this is in the chat also I have given. Go here, look at the conformance rules because these are the rules that you need to be aware of when you are working with the FHIR systems in the next session. So in the next session, the things that you should be familiar with is you should be able to load a FHIR resource, FHIR profile to a server, and then actually send a FHIR resource which is compatible to that particular profile. This is an exercise that you should be doing, and if you face any challenges, then we can discuss that on our discussion forum, right? And in the next session, we will actually start from the terminology operations like the expand and the lookup, right? And then we'll get into the details of what does it take to implement FHIR and what are the practical things that we should keep in mind when we are implementing.